Right, so question 1661 says, deep ultrasonic heating is used to promote healing of torn tendons. It is produced by applying ultrasonic sound over the affected area of the body. The sound transducer generator is circular with a certain radius and it produces a sound intensity of something. How much time is required for the transducer to emit 4,800 joules of sound energy? Right, so what I imagine this sound transducer looks like is like it's in the shape of a coin, say, and you put it on the affected area of your body, and what it does is it produces some sound energy, and that sound energy passes onto your body. But anyway, it passes out through the surface of this thing, and we're told what the surface area of that thing is, and we're also told the intensity at the surface of this transducer. So if we know those two things, in fact we don't actually know the area directly, but we know its radius, and so we can use that to figure out this area. So that radius and that intensity we can use to figure out what sound power is being output from this transducer. And if we know the power, we know how many joules of sound energy are passing out of this transducer every second. So if we know how many joules are passing out per second, we should be able to figure out how many seconds we have to wait before all those joules accumulate up into 4,800 joules. So that's what I'd like to do. I'd like to first of all figure out what is the power coming out this thing, and then use that power to calculate how long we need to wait for the energy to build up to 4,800. So anyway, what we've got here is we're going to have like a circular thing, I guess, and it has a radius of r. And at this point, the sound intensity I'm going to call I. So the intensity there is just 5,900 watts per square metre. And the radius, we are told, is 1.8 centimetres, or, as I like to say it, 1.8 times 10 to the minus 2 metres. And so I don't like centimetres particularly much. I would much rather work in SI units, so I'll convert that to metres. Now we know that intensity through this thing is given by the power passing through it divided by its area, and so therefore the power is just going to be equal to the intensity times the area, and the area we can easily figure out because it's a circle shape, and so this area is going to be pi times r squared. So this is going to be I pi r squared. So now we could actually go ahead and calculate a number for that. I'm not really keen on doing that though, because as soon as I start plugging numbers into my calculator, I tend to make mistakes. So I'm just going to leave it as a bunch of symbols for the time being. But anyway, what we want to know, if we did have a number for this, and we can easily do that, this would tell us the number of joules per second which are passing through the surface of this transducer. So another way of thinking about power, in fact, how power is in fact defined, is power is equal to energy transferred divided by the time over which that energy is transferred. So in this case, we know the power, and we know how much energy we want. We just need to figure out this time. So here we would just need to solve this equation for the time, and that's going to give us energy divided by the power. Now we want the energy to be 4,800 joules, I think. Yes, 4,800 joules. What is this power? Well, we've calculated that. So we need to wait. We want 4,800 joules. This takes a time of t is equal to E divided by I pi r squared. So here we just have, we know that, we know this, and we know that. So we can just plug these numbers into the calculator. So we're going to have 4,800 divided by the intensity, which is 5,900, times by pi, times by the radius, squared, which gives us 799 seconds. So we need to wait 799 seconds. And if we do that, the power, the cumulative power that will have passed through this transducer will have been 4,800 joules.